Let me introduce our next speaker this morning. This is Brandon Scott. He's an immersive technology applications engineer at APL in the XRCC team. He has worked on a variety of XR projects ranging from emergency care training, human-machine collaboration, biometrics, and XR collaboration. He has extensive expertise with Unity, 3D animation, and user experience design. Please welcome Brandon.
Hello, everyone. Can you hear me? Hear me well? All right. All right, today I want to talk to you about the AR CPR Coach update. We had a presentation before that, so I'm just show you the updates that we have. But before I go into the updates, let's go rewind it back and show you how this thing began. So back in 2020, one of our coworkers here at the lab, Scott Simpkins, who's in the red department, attended the 2020 National Health Symposium where he met up with Justin, Therese, and Keith, and they're all part of the Johns Hopkins Medical Pediatric team. And what Scott did was basically show them a tour of the APL lab. He showed them the AR and VR facilities, and they kind of worked together to kind of brainstorm different ways that they can use XR for healthcare, right? So with a little bit of thinking, what they were able to do, well, a lot of thinking probably, they were able to come up with this grant, and they were awarded a Delta grant by the Agency of Healthcare Research and Quality, AHRQ, and specifically what this grant was meant to do is to help improve pediatric CPR's performance and education using augmented reality. So before we talk about why we need to use augmented reality to help improve CPR, let's talk about the problems with pediatric CPR. So first of all, 21,000 times a year, there are pediatric cardiac arrests occurring across the United States. So if you look at this diagram, this complicated diagram over here to the right, you can see that CPR, pediatric CPR, is very difficult. You have to perform these strenuous exercises for like 2 minute long intervals. You have to stay within this narrow range of compression depth. That's how far you're pushing onto the chest and how fast you're pushing onto the chest. And because we're dealing with pediatrics, it's more delicate bodies. Like we're dealing with kids, we're not dealing with adults. So you have to be even more delicate with it. So it's even more difficult. So why can't you just train them? Just put them in training programs and they'll be better, right? Well, most of these hospitals are located in these rural areas and they're low on staff and they're low on funding. So that's really not possible most of the time. And a lot of the education teaches them to perform CPR in ideal case scenarios. What about real world case scenarios where they're in moving vehicles like EMS? What if they're outdoors? What if there are a lot of things going on? They're not really prepping people for that. And last of all, you just can't really depend on training because it's just infrequent and the retention of these CPR skills are very low. We have more problems. So Johns Hopkins University invented this CPR coaching system. So if you can look at this diagram, it's pretty much a bird's eye view of the medical room and all of the CPR roles, all the different players. And they're given by different shapes here. You have triangles that represent the nurses and they're moving around. You have this hexagon. I hope that's a hexagon. I can't count all the shapes. But you have this chest compressor, and this is the person actually doing the compressions on the CPR patient, right? And what this chest compressor is doing is looking over, across the bed, over to the CPR coach, and that's given by this circle here. And the CPR coach's job is to look at the defibrillator, which gives them the information to convey through words over to the chest compressor on basically how they should do the compression. So they pump faster, should they go deeper, should they go slower, all of that information. And then you have your resuscitation leader. It's kind of like the quarterback of this entire medical play. So you have all of this going on, and this is supposed to be the gold standard quality for CPR care worldwide. So what is the national adherence to this gold standard? Pretty much 30 to 50%. The best being the people who created it, which is only at 55%. That means half of the time they're doing it correctly. Why is that? Why is this situation where half of the time they're doing CPR correctly? Well, if you look at it, there's so many actors moving in tandem. You have these nurses moving around. You have the CPR coach trying to talk to the chest compressor. You have all of this noise going on. So there's a high probability for miscommunication. Imagine you're doing chest compressions and all these people are moving around. There's like a lot of talking. How can you really pick up that information correctly, right? So this high dynamic, even in this ideal environment, this golden standard, you have this cognitive overload that's going on with the chest compressor. So it becomes clear that real-time feedback, in-the-moment feedback to a performer is very important when it comes to ensuring the highest quality of CPR care. So this is where the augmented reality portion comes in. Video, I love videos. So if you look over here, you can see Keith, who's part of the JM pediatric team. He's doing CPR right now, but this is different. This is not traditional CPR. He has a headset on, and you can see in this computer, it's mirrored to what he's seeing in his actual augmented reality display. So he's looking at this display that we're seeing over here on the laptop. And what is this doing for him? How is this different from what it was before? Well, because everything's automatic, he's getting this precise, almost real-time, accurate feedback of how he needs to perform or how he needs to improve upon the CPR, right? And he's not looking at a person and trying to listen to what they're saying anymore. All of that information is on the display, so this really reduces miscommunication, the feedback miscommunication. And last of all, because he's not paying attention to all these people moving around, he's basically reducing the cognitive load it takes to do the CPR. So all of these things are mainly the reason why we wanted to use augmented reality to help coach the CPR performer. So how do we do this? Well, in phase 1, we wanted to create a proof of concept. Like, how do we put this thing together? So if you go back, you can see that, let me see if I can go back here. There you go. You can see that Keith is actually doing these compressions, and there's this wire connecting from his hand to the laptop here. So I want you to remember that in your head. So as he's doing compressions, there is an accelerometer or a sensor picking up that back and forth motion, right? And that information, that raw data, that back and forth motion is being sent over this wire or USB-C to this laptop that you were able to see before. And this laptop is basically doing the business intelligence. It's saying, like, what does this up and down mean? He's ingesting that data, processing it, and it's coming up with the CPR coach. It's deciding how to, you need to pump faster, you need to pump slower. So that information is sent over Wi-Fi to the augmented reality display, which is on his head, and that's giving him information through an intuitive user interface on how to pump, or how deep to pump, or how fast to pump. So that's pretty much the big 3 components that are together that's making this thing work, right? So I showed you the hardware. What about the software? What are we doing here? So you've heard a lot about Unity already. Unity is a software, it's a game development program, and it works really well with AR and VR. So we had to use that because it's just really nice to use. So it's very helpful when you come up with, for coming up with user interfaces, which is a thing that I primarily worked on. And they have a lot of third-party asset libraries that just make it easier. You don't have to reinvent the wheel. But one of the biggest things that I think is important here is that it helps build to iOS, Android, Windows, Linux. So you can be sure that if you have like a new augmented reality headset that comes out, Unity is going to be able to build towards that. So all of those reasons, those are reasons why we use that for the AR display. What about the actual IMU or the actual sensor when you do the pumping? We use CircuitPython for that. It has plug-and-play capabilities, so you can just literally plug and play and actually start working with that. They have a whole bunch of Python libraries to allow you to process the signal and filter that out, and allows you to just rapidly develop and iterate through that. So those are the softwares that we use. Let's actually get into how this display works. What is James here looking at? James is also part of the team. He's raising his hand over here. What is he looking at when he's doing this compression on this pillow who needs help? So what you can see here is that there's two important metrics that we're looking at: depth and CPM, or compressions per minute. What does that mean? Depth is how far I'm pushing on the chest. That's how deep I'm pushing, right? Compressions per minute is the rate. How fast am I doing the compressions? So we wanted to basically take those two metrics and think about it like this. Okay, if I'm pushing deep, that's kind of vertical, right? If I am doing a rate, or how fast, what happens if we make that horizontal visually? So now you're dealing with this vertical and horizontal. What if we use that to control a circle? And what you're doing now, effectively, is by doing CPR, you're doing a balancing act of trying to take that circle and keep it within that green rectangle, which represents your acceptable compression rate and your acceptable depth. So by pumping faster or pumping slower, you get to move the circle this way. If you're pumping deeper or pumping shallower, you're moving the circle up and down. So it's basically a balancing act. Another thing that we wanted to do is use color to kind of give you information on feedback. So if it's green, good. You're good to go. You're doing the right thing. If it's red, you need to correct something. So you can see that here there are certain metrics that start to turn red and it tells you you need to fix things. We also have that coach component where it's saying you need to go faster. You're going too fast. You're going slower, or you need to go slower. So that part is in the middle of the rectangle, giving you information like that. And last of all, if you're just messing up for some reason, you're just not paying attention, and your metrics go too far out for too long, I would say about 3 seconds, we have this grabbing alert system. So you can see something that's just flashing red. Wake up, go faster. So that information is there as well. So all of these things are considerations that we put in for the graphical user interface, and this is what pretty much James is seeing as he's doing the compressions. So the question is, does this thing actually work? It seems like it would be intuitive, but would it actually work out? So we have some tables here, and hopefully I can explain this well enough for you. So what we did was, basically back in 2021, we have about 9 individual subjects, and we wanted them to perform CPR for 2-minute intervals. And we asked them to do that for 3 trials, or 3 times. Let's see if I can get this right. So the first trial, the first time, we basically said, don't use a headset, do it traditionally. So we got them to basically do the traditional one. For the second trial, we kind of flipped the coin. I don't know if it's a coin. We have to be specific on that. But there's a probability on whether they used the AR headset or they didn't. So if they didn't use the AR headset for the third trial, they would use the AR headset. If they did use the AR headset for the second trial, they would use it for the... If they didn't use it, they would use it for the third trial. So it's basically the second and the third trial, you flip whether you use it or not. And we'll explain, when you look at subject 6, it'll all make sense. So let me show you subject 4. Each one of these rows on this table represents a certain trial, right? So you can see here, I wish I had a laser pointer, but you can see here that on the first trial for subject 4, they did no AR. They basically did CPR with no AR. And you can see that their depth is very bad. They were right 0% of the time, and their rate is also like very bad, right? So we asked them, okay, we roll a die, and we say, oh, okay, you're not doing AR for the second round. For the second round, you can see that the rate started to improve. They got into the rhythm of doing the rate and the compressions. Their depth is still bad. But look what happens on the third trial when they start to use the augmented reality headset. We're talking 90 percentile for both depth and rate. So you can see right here that the headset is actually giving you better performance, right? But what about subject 6? What do we do here that was differently? So the first round, you can see that they had a rate about 50% of the time they were doing it right, and their depth, not good. They're just doing bad on the depth for some reason. And this is with no augmented reality headset. So second, if you look at the second round, this time, we're going to ask them to put on the headset. You can see that their performance improves dramatically. We have a rate of 90%, and their depth is about 80%, right? But now, we're going to ask them to take off the headset again and look at their rate. It improved. We have the depth. It's not the best, but it was better than it was before. So what does that indicate? When we swap them around, that indicates that there's retention going on. So it kind of makes intuitive sense. If you're putting on the headset and you have a certain correct rate, you take it off, you kind of remember what it was like before. So that kind of helps out with the education part to teach people how to do it better. So this is just the initial feasibility test on whether, is this actually working or not, and it turned out very nice. So we went on to go on to many publications. We have publications in Resuscitation Plus. We have publications in the previous XR Symposium, the International Meeting for Simulation in Healthcare, which was this year, 5 conferences. We even got the limelight out here in the APRO web article. You can see that we have Blake and James over on the sides, and they're actually in the respective spots. I don't know, like trying to get the and in the middle, we have Keith from the actual pediatrics team for the medical pediatrics team. So this is pretty much the publications for this. So that was giving you what we've already done. We're going to talk about what we're working on now, the actual update portion. So phase 2, how do we make this thing better? Okay, so before I go ahead and explain this, let me go back to that animation here, or not the animation, the actual real video. He's a real person. So you can see as he's doing this compression, there's this sensor in between his hand and the actual mannequin, and there's this wire going on and connecting to this laptop. There's a lot of components here, and it just looks kind of, if you're trying to do something important, you don't want all these pieces here. It's very cumbersome. So I just wanted to give you that visual before I actually go in and explain what we want to optimize here. So you can see here that there are 4 components that we already have for phase 1. For phase 2, we want to go ahead and reduce that. Do we really need the laptop if the AR display can do all of that processing? So we want to combine those 2 together, right? Also for the sensor, we have something called, there's an issue with the sensor called sensor numerical drift or dead reckoning. And don't get that mistaken with the new Mission Impossible movie that's about to come out. It's dead reckoning is this issue where the sensor is basically trying to guess where it is, and it makes these small mistakes every time. And it kind of builds up to cause it to drift away dramatically from what it was, where it thought it was, right? So basically the sensor is not going to be accurate over time. And what we want to do is just get a better sensor. So even yesterday, we had a meeting where we were basically looking at different sensors, how they worked, and trying to evaluate whether we could use this and trying to brainstorm whether it would work or not. So we're in the process right now of finding better sensors that will help us in that situation. Another thing is that big that USB-C cord that connects while he's doing the compressions. You don't need that. So is there a way that we can make this sensor wireless? So all you have is basically a headset and a sensor in between, and you're doing the compressions, and that information is wirelessly sent to the headset. So that's what we're working on now. You want to make sure if you're doing a lot of networking, you want to have security issues. I mean, well, you don't want to have security issues. You want to have network security. You want to have network security for that. So that's another thing we want to build in. The bigger thing, I would say the biggest thing that we're trying to implement now is rate is what we've been focusing on, and depth, how far you're pushing into the chest. But another thing that's very important is called chest recoil feedback. So if you think about CPR, what you're doing is you're pushing blood out of the heart, right? And a big thing that you want to do is kind of relieve enough pressure onto the heart to let the blood flow back in. And if you don't do that, then you got problems. So what we want to do is be able to have a sensor that can pick up when you're basically giving the chest enough recoil to allow the blood to come back into there, and send that to the headset and have a non-invasive way, or you don't want to shout like that, how we had that alert system. We want to find a fine, delicate balance of putting that onto display as well. So every new thing that we put on display is this kind of balance of, are we overloading you? Are we giving you too much information? So we're still working on that portion there, but we do want to put in chest recoil feedback. And last of all, our future endeavors here. We want to, remember I told you that the training is really focused on this ideal circumstance or ideal scenario here. Over on the right, you're focused on this medical room. But we want to test this thing outside of that. How does it work in the EMS when there's a lot of this going on? There's a lot of noise. Like, how do you deal with that situation? We still want to do more UX testing and make sure that this display is working out intuitively. We can work out all the issues with that. And last of all, what happens if you put this headset on all of the other roles? The pharmacist, the team leader, the bedside nurse. How more efficient can this process become? Can we get it from 55? Can we improve that a lot better to where it adheres to standards? So that was a mouthful. I am pretty much done with this, and it's up to you. Should we go into questions? Or? All right.
How's it going? So I had a question or two. Have you looked into implementing things like LiDAR as well as photo, like no sensors that are on your hands, and just using data directly from like what's your image and LiDAR?
I'm going to WWE tag team in James for this one.
So Brandon and I yes, we have. In fact, Brandon mentioned during his presentation that we had a discussion yesterday with the team lead on what kind of sensors we're going to have. That was of primary importance. The big concerns that we're having in a little bit higher detail is we want to make sure that we're tracking the positions of the hands relative to a stationary reference frame so that we can get the accurate value of how much you're compressing at the point in time. The concerns behind that are how much visual, audio, like noise is coming back to the sensors to degrade the quality of And as we've come to find out, not a lot of systems are really good at linear motion. They're either just accelerations and orientations.
I guess the second question I had was, do you see this sort of technology being useful for lifeguards and situations where you might only have 1 or 2 lifeguards that are actually trained, and being able to bring someone from the public who may not be CPR certified like a lifeguard is, and being able to strap on something like this and have them step in as one of the roles in a life-saving event?
So that would be more like, are you saying in real time with like no training and before?
Real time.
That's interesting.
Future vision, yes, we want that, but we're not there now.
Yeah.
Cool, thank you.
You gotta prove it works first.
Hi. A large part of the question I'm about to ask, you started to answer in your last slide, talking about noise and other things that somebody might need to pay attention to in this environment. But I still think it's worth asking, especially in Subject 4 and Subject 6, talking about the successful use of the successful performance of the task wearing the headset versus the retention of the information following wearing the headset. Which of these do you think is more interesting or provides more opportunity in terms of solutions? Are you more looking at, here's how we envision somebody using the headset to do this? Or is it, here's how we think using the headset will better make somebody able to do this without the headset? The reason why these two concepts I think are linked is you're likely going to be continuing to explore spaces where people have multiple layers of data and multiple simultaneous overlapping tasks. So I was just wondering if you could speak to that at all, about whether you think the problem is more important on the, we want to wear the headset to do the task, or we want to wear the headset to learn how to do the task without the headset.
I can handle that.
Yeah, go ahead.
Yeah, that's honestly a multi-layered question. The first phase of this project was designed to see if it's even feasible for us to do this at all. The ultimate goal of the project that we still have is, one, we want to save lives. And we want to not get in the way of the user when they're trying to save a life, right? So any bottleneck or hurdle that the user faces when they put on the headset, when they turn on the system, when they get to perform CPR, those are the critical components that we're trying to solve. So with that frame of mind, obviously you want to see, is this actually feasible? And this study says absolutely it is feasible. The next problem is not so much how do we envision how the headset's being used, but what is the best form factor for a headset to get out of the way of the performer, such that they don't have to give second thoughts about how do I put this on, how do I turn it on, how do I adjust it, right? Because those are seconds that can save a life or not. So functionally, if it turns out that we aren't going to be using headsets in the future, if the evolution of this project says we no longer use headsets, that's fine. And that may still be the case in the future. So, but we're looking at this in the mind frame of, again, what are the hurdles that the users, the intended performer, is going to face when they use these headsets?
I'm guessing, based on the design that you showed, that there's not an evolving layer of data that changes what this user is going to need to do. They're trying to do a standard procedure,
right,
not responding to real-time changes.
Right. And a more future-looking concept that we're kind of toying with a little bit, and this is like far-flung into the future here, is you may have picked up on that a single performer inside of the emergency room environment is getting one single data set. A separate performer who may be doing something other than CPR is probably going to be receiving a separate data set. Another one's going to be receiving a third unique set of data sets. You'll probably want to have all of that coalesced into a syntaxful or context-aware data visualization, of which the leader of all of these team members are going to be receiving. And that's something that we're slowly paying attention to in the back of our heads, which will probably evolve into some form. But for the short term, we're not really focused on that at this point in time.
Hi there, Mitzi Herrera from Montgomery County.
Maryland, just down the way. A couple questions. And let me sort of say I wear two hats. One is Montgomery County looking at training and various things, healthcare and so forth. The other one is I have a large family, not just extended family, and we are reaching the point where several of them are now having second, third generation. And one of the things in my family was we should all try to take pediatric first aid as a goal in there. So looking at what you've got, I'm trying to understand is your goal one, that I could have a software and use an AR headset and actually take that training, you know, so I could go to a library, I own one, you could do that. Or second, am I going to a first aid class and they're using it in tandem with a dummy to actually practice and, you know, get some feedback as to how I'm actually doing it correctly, which you do get a little bit when you use I can't remember her name was, Annie is the one that we used to do it with. And it would it buzzes yes or no, like whether you're doing it right. And then the third is the goal that I'm in a care unit in a hospital and the healthcare worker, or in the ambulance and the healthcare worker is using it so that on an actual person, I'm improving and getting real-time feedback that I'm doing it correctly. So first I'm trying to understand either where are you at or where are you going in those three applications?
I can answer that one. Yeah, so where we are going, the ideal state is is not training focused, it's actually performance focused and deployment of the device of the project on the field. What I mean to say is that it's going to be the latter, or the third option you mentioned, right? You have an emergency situation, someone just collapsed outside on the floor, emergency responders coming in, then they put on the headset and begin performing CPR right on the spot. The reason why we're pushing towards that is because, as been mentioned in one of the slides, you have rural hospitals that don't have appropriate training and don't do regular training, particularly for pediatric patients. And the level of quality you have to have is much more stringent for pediatrics than it is for adults. So with that being a multi-factor of problems, we can't really rely too much on training and training to be regular. So it's better to actually say, if you have to perform CPR on a patient, throw on the headset, follow what the headset's telling you. And we also want to do that for, you know, if you're in an emergency ambulance vehicle and the ambulance is doing all of this stuff, right? So we're leaning towards the end stage of this is an actually deployable system that you can use at an emergency site.
So beyond the cost, well, I guess, is it designed for something like a commercially available Quest, what is it, MetaQuest? Oculus, it's the under $400 headset,
Yeah.
right? Yeah. Is it designed for that, or what's your sort of, between the cost and what you're envisioning as the software?
Right. Yeah, that's an ongoing investigation. We have developed the project to be agnostic of device, to start with. And this allows us to explore the project in two different directions simultaneously. One is what headsets or what devices can we use to visualize the data sets, because it may end up actually being your personal cell phone that you only have available with you at that point in time. The other one is, without bumping into each other, is how do we actually improve the quality of the visualizations and the data sets on that side. So we don't have to worry about the headset itself so much as what is the form factor of the headset, what is the best way for the headset to be formed such that it doesn't get in your way. And again, I mentioned if it turns out that it's not headset at all, if it turns out to be your cell phone, great. So we're not too heavily focused on what headset we want to be aware of, because we know that there's going to be numerous headsets in the market. We know they're going to be at various price points. We know that the emergency responder may not even have any available to them. And we want to be able to resolve the problem of quality CPR without worrying about the type of heads that you have available.
Okay, and then last question. Are you doing it in real time, deploying it out in the field anywhere? Do you have to address any legal in the beta? And is it subject to a similar FDA where you've got to go through an efficacy test before you release it widely?
Yeah. So this test was not an FDA-approved test. It was just to say, like, is this actually a feasible thing that has long-lasting effects, which it does. We're working very hard now to upgrade the system such that we are able to do an FDA-approved efficacy test. And one of the biggest hurdles, this is a little more technical, but one of the biggest hurdles we're facing right now is the sensor that we're using currently does not have a frame of reference at all. So we're heavily guesstimating what the actual compression depth is. We can get the rate pretty fine because that's acceleration. The linear motion is very difficult with a single sensor. So that's one of the first major hurdles we're trying to solve at this point in time to get to the point that we can do FDA-approved testing.